Going back to the netlist file, we're going to take a look at how to create a netlist file from this LT-Spice. Now, netlist file format is a format which is a standard according to which you can list out all the components in a given architecture. Now, there are different types of netlist files. There's Express netlist, there is Spice netlist, and they all contain the same information, just put in a different way. For now, we're going to talk about how to create a Spice netlist file, and then we're going to upload the Spice netlist file into SLIKWORKS. So if you go to View and Update and View Spice netlist, this is what the file is going to look like. This is the location, this is the LT-Spice version, and it's going to list out all the components, all the sub-circuits, and it's going to also mention the relationship between all these components. Now, why this is important? In this example, we've taken a small circuit of an ADC, which has about 8 components. It might be easy to manually enter 8 components into SLIKWORKS and then do the FMEDA. But imagine if you had a bigger circuit where there are 200 components. It does not make sense to manually enter all of them into the FMEDA. So there has to be a better way to import files. And here, using the Spice netlist is a very good way to import the file. So now that we have the file, we are going to import this into SLIKWORKS. Back to the SLIKWORKS interface. So we're going to click on Upload Netlist, and we're going to go to the location where the netlist file is stored, and then double click on it. It's going to take a few seconds, and then it's going to upload it. And what it's done is it's parsed the entire .NET file, and it has identified all the components, and then it populates it over here. So for example, the first component is V3, that's the name, it's a voltage source. Subtype, if applicable, this is populated because this is subtype is going to be used in calculating fit rates. Fit rate for now is not set, and we're going to come in a minute how to set it. Then it talks about nodes. These are the nodes to which V3 is connected to in the circuit diagram. And this is the value of V3. In this case, it is 1.8 volt. The values are not so important, at least for voltage sources. They get important when it comes to resistors and capacitors, but for voltage sources, they're not so important. And then there is a status, which talks about is all the information for each of these components available. So what we have now is, with the click of 2 buttons, we have all the components from the circuit diagram onto SLIKWORKS. Here we have 1, 2, 3, 4, 5, 6, 7 components. Imagine a circuit that has 200 different components. How convenient this is to be able to just upload all the 200 components with just click of a button. That is the value that SLIKWORKS is offering. Now that we have all the components, now we're going to take a look at what is it that we can do with each of these components. SLIKWORKS offers the feature of bulk editing. With bulk editing, we can see what is the subtypes. We can bulk edit the subtypes, which is this. We can bulk edit the failure rates. We can bulk edit descriptions, and we can bulk edit failure modes. So let's start with a simple thing. Let's say we want to edit the failure rates of all the voltage sources here. So I go to bulk. I could first go to filter, and then I just filter out all the types of voltage sources. Now what I would do with bulk edit is then say with the failure rates, I'm going to choose which component. Right now, the current fit is not set. I can give I can give any fit value. I'm just going to give 5 fit over here. Let's say this is coming from the specification of the component, and this is 5 fit. So now you see that all of them have 5 fit. Now let's take a look at another component. Let's take a look at the resistor. With the resistor, what we can do is we can again go to bulk edit. We can modify the type of resistor. So we can say resistor, and then we say whether we want to keep it as a fixed composition or we want to make it a fixed film. So if you want to make it a fixed film, just click on this and then click on save. So it's changed to fixed film. Then we can change the failure rates. With the failure rates, there are 2 options over here. One can manually enter the failure rate, or 2, they can auto-calculate the failure rate using the mill handbook. For simplicity, we're going to consider the manual failure rate entry. And at a later point, we're going to see how to do the auto-calculation. So let's assume we have the data sheet for the component, and we know the failure rate is, let's say, 10 fit. It's a very high value, but let's say this is 10 fit. Then we're going to save it. So it's entered as 10 fit. Now we have all the data ready for this, so it's marked as complete. Similarly, we can do the same thing for capacitors. And then we have the subcircuit, which is XU1, which is the ADC. And let's say the data sheet of this subcircuit also talks about what failure modes be. So then we go to failure rates. The subcircuit, and let's, for example, say it is 0.1 fit. And this is coming from the data sheet. So here we have it. We have all the components, we have their fit rates. The next thing is we need to identify failure modes for components. Now, if failure modes are not already available, this would be incomplete. What we have today is an internal database of failure modes and their distribution, which is why it's saying complete. But the user can also modify this. So let's take a look at the subcircuit and let's see how to modify its failure. So I go to bulk edit and then I go to failure modes and then I can choose which component do I want to modify the failure modes. The subcircuit, and in this case it's just 84,000. That's the only subcircuit available. If there's more subcircuits, it will show up over here. And then now we have just 2 failure modes over here. So too high ADC value, say 50%, too low ADC value is 50%. You can add a new failure mode and its distribution. But for now, let's assume that it's too high and too low. And this is coming from the data sheet. So we can save this. Similarly, we can take a look at the resistor. For the resistor, we have bulk edit, go to failure modes, then look at resistor, and this is what we have, and then we have 3 failure modes. So there's open circuit, there's resistance drift, and there's short circuit. Now, the user, it is possible for the user to customize the failure modes database as well. But for now, we're using an inbuilt database. So far, what we have is we've uploaded all the components. We've identified the fit rates of the components. We've identified the failure modes of the components. So we have everything set up to go ahead and perform the FMEDA. Notice that how easily we went from a circuit diagram to creating, uploading all the elements here and identifying its failure rates and failure modes. This is a big value add for a customer.